Hello sir, as a part of our project phase 1, we are conducting a review presentation on our project named as Microstructural Analysis of Surface Modified Aluminum Alloy using AAO, which is nothing but anodized aluminum alloy. And our project, our team is myself Shivraj and my teammate is Siddhi Vibhute. So let's see.
Now I am explaining about the AO background, that is anodized aluminum alloy. So for this we are considering our aluminum alloy as an anode and we are taken cathode as a pure aluminum. Then we used electrolyte of sulfuric acid. So we give the DC supply, and then when we give DC supply, there are the formation of Al2O3. Al2O3 is formed and then it is deposited on our anode, that is aluminum alloy. So this is our setup. Here this one is our DC supply, then this magnetic stirrer, 3 is cathode, that is we are using aluminum, pure aluminum. Then 4 is our anode, that is aluminum alloy. 5th is our holder mechanism and 6th is cooler. So here we added cooler from our previous project because we performed coating for less than 1 hour previously, but now we are increasing the timing of anodization for getting the more thickness of coating. So that's why we to maintain the temperature we are extra added the cooler. So this is the research paper. This is the literature review of the research paper. The research paper name is the effect of anodization treatment on the microstructure and fatigue behavior of 7075 P73 aluminum alloy. The author of this research paper is Shishi. So in this research paper, they take the aluminum alloy 7075, which is again heat treated with the T73. In this research paper, they are performing the anodization on this alloy, and then checking about the microstructural changes, fatigue behavior enhancement, fracture surface analysis. In microstructural changes, they are observing the precipitation dissolution. In this 7075 alloy, there are extra elements such as the magnesium, zinc and silicon. The magnesium and zinc are dissolved with the aluminum matrix, but the silicon is not dissolved or partially dissolved. So that's why they are seeing some precipitation on that, and also grain boundaries formation. So due to anodization, there are some grain boundaries are formed. So they are observing that also. Then about fatigue behavior, so they observe that they compared the anodized sample and unanodized sample. So in that they observed that when we anodize the sample, the fatigue life of that sample is increased. And about fracture surface, so they also observed that the spacing of the fracture we are getting fracture. So this also increased when we perform anodization on the that alloy. And then the next part will be discussed by Shivraj.
So now we are seeing microscopic analysis. So we have taken a research paper. From that we have find that some critical techniques used to examine the microstructural analysis of the material. So in that we have found OEM and SEM, optical microscopy and scanning electron microscopy. So from that we can visualize the oxide layer thickness, means how much thickness is segregated or added onto the surface of our specimen. So we can find that from the optical microscope and scanning electron microscope. So and next thing is porosity. We can find the porosity of the material, means the porous, means as we know the porous layer and barrier layer segregated on the specimen. So we can find that from the presence and distribution of the pores. So we can find from that is uniformity of the coating, means how much in how much percentage the coating is uniform. So we can found porosity. Next thing is morphology. We can found the shape, size and orientation of oxide grain boundaries. So we can found from the morphology. And next thing is interface structure. So we can find the interface between the oxide layer and grain boundaries. This underlying metal matrix, we can found the interface structure. So we can see deep into the matrix layer. And next thing is precipitates. So identify and characterize any precipitates within the oxide layer and or we can say metal matrix. So precipitates are there or not? How much optimum thickness we got for the coating. So these things we can found, and some defects also we can found, like some defects such as dissolution grain boundaries and twin grain boundaries. So from the microscopic analysis, these things we can found easily. So these are images. You can see here are some optical microscopic observations showing from top view of the microstructure of 7075. So talking about the 7075 aluminium. So why we choose for this? So aluminium AL7075 is the most used material in the aircraft industries. So that's why we go for this specimen. And this is the transmission electron microscopic photo indicating precipitation morphology. So here you can see grain boundaries and metal matrix of the specimen. So now tensile test. We are performing this test for knowing the mechanical properties or different properties of the materials which are increased by the coating. Means before coating, what are the properties? Means how much they can sustain with their load, or we can say any other applications, for any other applications, and what the difference after the coating. So we are finding this by tensile test under UTM universal testing machine. So in that, so we have found the research paper. In that they have mentioned that ultimate tensile strength and yield strength increased by the difference of 10 megapascal. 10 megapascal is a huge difference, as we can see. So that's why we have choose this tensile test for our project. And ductility property of the aluminium alloy will also increase after the coating. So this is our Gantt chart. So first we have selected research papers and give literature review. And so in second week of August, we are collecting required product industrial visits. So we have already visited one industry related to our project, and we have constructed in holder mechanism in third of week. And I-scan registration. This is about the laboratory. If we have to use external laboratory source like SCM scanning electron microscope which is in Shivraj University, Kolhapur. Pre-processing of sample before going to microscopic analysis. We have to pre-process our sample for this high resolution or better results, to magnify the image to get better results. We have to pre-process the sample. This we will do in 5th of August, and then we will analyze our sample, and then sample preparation for microscopy. Again we have to prepare sample for microscopy, and then we will take the images under the microscopy. So that is our part of microstructural analysis. it will be happening third of week estimated and comparing mechanical properties after and before anodization. So in next week we will be focused on the comparing the mechanical properties results and after the anodization and before the anodization. And so next part is our industrial visit. We have visited a company which is situated in Gurgaon, a company named as Mirza Plastics Private Limited, and we have visited the company 2nd of August 2024. So this company mainly make the metal labels by anodizing, means to make the shiny to the number plates or name plates, which is to showcase the precautions or any danger or name plates or rules and regulations for the instruments. So they have made like these materials like promotion metal label, printed metal label, advertising metal labels, and publicity metal label. And these are some visits photographs. This is the one of the photograph. This is the owner of the company named as NK Mirza, and these are some samples which they have created. This is the nameplates of some instruments, and this is the setup of their anodization laboratory. So in that they can dip their samples and make the specimen anodized. So here are some reference papers. We have taken the data from this